Good morning and good afternoon, folks. I really appreciate you guys joining us on the third edition of our webinar series with R2A. Today's presentation is more about the AI and what we're doing with AI to basically run a Wi-Fi network and make lives easy for our folks in IT as well as the rest of our company. So hope you enjoy it. Feel free to ask questions in the Q&A panel, and let's get started. So our first webinar back in December was an introduction to R2A, who we are, what we do, and the basic concept of artificial intelligence-based proactive Wi-Fi as a service. We hope you got a lot of great value out of that presentation. We really think that proactive Wi-Fi is the way to go, and the service model really makes it easy for us to deliver a lot of value to customers because we can manage and monitor and give them all the information they need at their fingertips. The webinar 2 was about an insight into the types of Wi-Fi problems we're solving with AI. And most of you in your day-to-day jobs, you probably run into performance and connectivity issues. Most of them are user-reported. They keep you up at night. A lot of these issues could be because of BYOD or devices that are beyond your control. And what we're trying to do with AI is try to identify a whole bunch of devices that may or may not be in your control and give you visibility into the types of issues they create into the Wi-Fi network. Webinar 3 today is all about the AI. Our expert system in particular helps us troubleshoot and optimize Wi-Fi performance and connectivity issues. Expert system is one part of the AI. There's machine learning and analytics that's to come later. What we're doing with our expert system is to really build the core of our AI system, the brain, that helps identify what types of issues are out there and resolve them one by one so that you don't need to do those. Okay? So traditional reactive response is pretty slow. We know that when a user reports an issue, it goes through a variety of different steps. It gets reported to you. Sometimes you have the solution right away. You can patch it. You can come up with a workaround. But sometimes certain issues require you to go back to vendors. And just imagine this. In today's world, and you'll see this in a few slides, there's at least a dozen or more devices that you're going to have to deal with in a small office environment and many more in a larger office environment. Most of the devices are from Apple or LG or Samsung, and they have a variety of different issues that they create that may require you to go back to either the carrier or to the device vendor or even the network vendor to figure out when the issue actually happens. The resolution could take anywhere from a few hours, if you're lucky, to a few days, and sometimes the resolution could even be temporary. There's no guarantee that those issues will not recur in future occurrences. So I think an important part of traditional reactive response is the fact that you have to go through multiple different steps to get to the resolution to a problem. What we're doing with proactive response using AI is using machine learning, using big data, using the power of cloud and the scale of the cloud to really harness all the health parameters that are involved in any Wi-Fi network. And most of you have probably seen the kinds of health the parameters that your devices can transmit. These could be things like link quality, cell size, radio performance, the types of devices, where they are in the network. And our ability to harness all of that information, put it together in a very systematic format, and then troubleshoot it on the fly is where our value proposition to IT is. That requires a lot of computing and data management scale, and our artificial intelligence system is attempting to solve those kinds of problems using the scale of the cloud and the data that we can harness to the Wi-Fi network. Okay? The end resolution is that you can start to see performance improvements in a matter of seconds or minutes. You will see improvements at the device level, at a user level, not just at a network level, which is hard to quantify to our end users. Okay, so here's a quick summary of our Wi-Fi as a service, and it's sort of a reiteration of what we said in the past. We offer a comprehensive service where we integrate cloud-managed Wi-Fi networking. Cloud networking is now the de facto in any kind of networking, so that's a starting point. But more importantly, we integrate proactive services based on AI, and we help you operate the network using 24/7 monitoring from our own NOC and as well as our own RF experts. So you really don't have to develop deep expertise in wireless LAN. You can rely on us to come in with a lot of the support needs when you need it. The AI itself is a set of patented rules that we've developed for diagnosis, correction, and performance improvement. We continue to work on these. We're actively contributing to the AI community with new patents and around networking and Wi-Fi. And at some point in the future, our CTO will be happy to share about how we've evolved in this space. But this really is the secret sauce to how we run the Wi-Fi network. And then finally, our 24/7 monitoring and proactive support. No AI system is complete without the supervision of a 24/7 monitored environment. And what this is basically our RF experts who are looking at the results that the AI system throws up and say, is this really the machine learning learns the patterns and the behaviors over time and feeds that back into the expert system so that the more accurate responses we need, we rely on the data that comes out of the machine learning engine to run the expert system. And the analytics is a bunch of views and reports that we can generate out of the AI system. And then the parameters that feed the algorithms are controlled by the expert system. Initially, the system is going to be trained by humans, so it really requires us to take an active role in defining the rules and then identifying patterns. But over time, the machine takes over to relieve us of all the heavy lifting that's needed in operating the expert system, and the expert system runs itself. Okay. So we continue to work on this area. The expert system is the one that monitors, troubleshoots, and takes appropriate actions related to various aspects of a wireless LAN system. Now, no troubleshooting is complete without looking at the system end-to-end. So when somebody reports an issue to you, whether it's a connectivity issue or a slow connection speed or whatever, you really have to start looking at not just the Wi-Fi, but also the network. And sometimes a poorly designed network or a network that's not sufficiently keeping up with the demands of the user applications can become the bottleneck. So we look at it from an end-to-end perspective. We start with the Wi-Fi, but then we can expand our troubleshooting to include the DNS servers, DHCP, the radius proxy if that's set up, and also security and other aspects of the network, such as latency, end-to-end, and such. We proactively optimize the wireless LAN performance with the expert system, and what this does is, takes health parameters that are pretty well known in the industry today and are operated as configuration knobs, and we automatically tweak them. Our system does not need someone to go in and try and do some experiments to see if the performance can be improved on the fly. The system automatically, based on a set of rules, adjusts the parameters, and once the outcome is desirable, then it stops adjusting those parameters. There are ways for us to check in and probe on the performance periodically so that we don't take it for granted that once we tweak the knob that it's going to resolve all performance issues down the road. And then finally, the system proactively identifies and corrects them. This is a very important part. Correction is something that usually takes many different steps to come to a conclusion. And what our system does is, based upon the understanding of the behaviors and the trends and the patterns, come up with a recommended action so that our NOC and our IT can work together to look at the performance in real time and say, okay, this problem that occurred at a particular time was resolved accurately by the expert system. And there are cases where we're kind of eliminating false positives here and there, but by and large, we have seen dramatic reduction in involvement by our IT and a NOC team in troubleshooting day-to-day problems. Okay. All right, great. So let's move on to the more details on the expert system. So this is human-like diagnosis. What it means for IT is, you really don't need self-support, so save a ton of time by not going to community forums and looking for answers. And sometimes if you do get an answer, you might be wondering whether this really applies to me or not because you don't have full context of your environment. We eliminate all those kinds of uncertainties. You don't need to have to maintain a support contract with a vendor because, support contracts generally only tackle known issues. And when you start contacting a TAC engineer in a vendor, they're going to ask you a whole set of questions starting from day zero, like what was the LED like, how many different users were there, what types of performance issues were occurring before this one occurred, and how many applications were in use. And these kinds of questions can really throw you into a spin. So we take away a lot of that by monitoring and harvesting that information in real time so that you don't have to deal with that when you contact our NOC engineers. There's no sifting through logs or packet captures. We'll never send you any of that information unless you specifically ask us to. there's no spending days and weeks trying to get problems resolved. The biggest advantage is that recurrence usually happens because the environment around you changes. And what we do is we adapt to the environment. So the more number of users and the more data and applications that are being used, the better our system gets. We can correct at machine speed and accuracy, and then the system detects and corrects problems before they become user observable. So that the users generally are happier. They don't have to open case tickets. You don't have to spend a ton of time, closing cases and entering information and trying to pencil in, notes for the future. All of those things are eliminated with our system. All right. So from the last webinar, we asked a bunch of questions around, what types of devices cause you the most pain, or what issues keep you up at night. In terms of what the types of devices cause you the most pain, the respondents basically came back and said, smartphones, by and large, are the largest problem creators, followed closely by laptops and printers. There are other devices as well that can interfere, but if you say like 90 to 95% of the issues are caused by everyday devices that are being used on a frequent basis, you really want to be able to understand what these devices are, what kinds of problems they create, what are the manufacturer specifications that could be leading to those issues, and having visibility into that and the right kind of conversations with the vendors down the road would be a huge benefit to IT. I know that for our IT team, it's a massive benefit because they don't really have to spend a ton of time talking to dozens of vendors. They talk to one or two different device vendors. What Wi-Fi issue keeps you at night? This was interesting. It's almost equal across the board, but I'd say that connectivity, dead zones, and upgrades are one of the biggest issues for respondents, followed by upload and download speeds. So this is good because the kinds of problems we're solving for with our AI right now are around connectivity and speeds. Security and BYOD are a close second. Security, as you know today, is an end-to-end philosophy. And BYOD is generally related to the types of configurations the devices come pre-configured with, and IT either knowing or not knowing what needs to change to adapt to the network that they're supporting. But the punchline here is, even with the best wireless LAN solutions in the market and the best designs, you'll find that performance and connectivity issues continue to bother you. And we're trying to help IT eliminate those kinds of issues down the road. So in terms of performance, what do we see at R2Wave? So we're dog-fooding our own technology. We've deployed AI in our own wireless LAN system to tackle issues that we think can be solved by the AI system. We don't want our IT guys spending a ton of time with individual users looking at their smartphones or their configurations on their laptops, trying to figure out what's a problematic configuration or not. We want our IT to be doing more strategic work, integrating cloud services, helping us scale our marketing and sales functions, and so on. So in terms of performance, what we see is the AI continuously improves throughput in our network on a client-by-client basis. And we have some data to share with you that quantifies this statement here. We can track and report single or 7-day rolling average of performance. So if you're an IT guy and you've been asked to report on a daily basis, our system can provide you that report. It could be compressed to only give you the most important details, or it could be expanded to see what types of devices are there, what kinds of performance issues being resolved. Are they relevant to your network per se, or are they something that are introduced by rogue APs or devices that are beyond our control? A NOC only responds to level 3 performance issues. We have a NOC. It's a pretty well-trained RF experts, and then they only respond to issues that are uncorrectable. And you'll see these in a bunch of future slides where we classify some issues as uncorrectable. We continue to work through our system and our technology to see how we can eliminate uncorrectables, but right now where we are, there are some issues that our NOC teams can respond to in real time to our IT. But we only proactively alert IT when these issues are beyond NOC's control. You don't want IT to be picking up phone calls about performance issues if the NOC can take care of those. And finally, we're seeing daily throughput gains by client. Our clients, our users are happier. They don't have to report cases to our IT. We run a lot of our own voice and video over Wi-Fi. In fact, right now this presentation is going over our own Wi-Fi network. The throughput gains are amazing. We're not seeing a lot of issues popping up on a daily basis. And the same goes for connectivity as well. in terms of connections between the AP and the device. When our devices roam from one room to the other, we don't see any issues with connecting to the network. You can maintain the IP address across the rooms. And more importantly, as we start to expand the network to add more and more devices, our technology can automatically detect issues with clients and resolve them. And we can do the same thing in terms of reporting, track and report on a single or a 7-day average. And more importantly, we're also now seeing productivity gains by client. We have some data to share with you on that front. So what's this doing to our IT? Basically, they got a bunch of free time now to spend doing things that they really enjoy. Whether it's taking time off with the family, learning new skills, watching the Warriors games, helping us deploy applications faster in sales and marketing and operations, or just enjoying more of their spare time to things that they really enjoy doing. And this is important for us because we don't want IT to be boggled with issues that can be resolved by machines. And there are issues where we really need IT to step in and play a leadership role and resolve, but there are a lot of other issues where we think that IT doesn't need to get involved in. So our IT is much happier now. Here's a first view into how we look at our own technology. So the AI and the NOC, they work together to operate the wireless LAN. Most of the mundane troubleshooting and diagnosis is done by the AI, and the NOC gets informed only when the AI cannot resolve an issue. So our IT can focus on business problems and strategic issues. Here's an example of what we saw in a 7-day window in the last week of February. We had about 11 access points in our own office. At any time, we have 78 unique clients that are connected. And interestingly, we got 9,300 connections or connection attempts to the network coming out of 78 devices. So that's a pretty powerful story right there. Now, you might say, well, 78 devices on an average, you're talking about 100 different connections or 150 connections per device. Well, that's because devices go in and go out pretty frequently. They move from one end of the office to the other. As you join new networks, new SSIDs, that's considered as a connection. So we have a bunch of SSIDs in our own network where users can connect to automatically, and that creates the connection density over here. More importantly, what our AI found was that there were more than 500 issues related to performance, and these could be related to download speeds or upload speeds. And we ended up solving, or the AI solved about 378 automatically. These were issues that our IT team didn't have to get involved in. There were about 130 issues that were uncorrectable, and our NOC got involved in looking at some of those. But by and large, we were able to solve over 75% of the issues using machines. And the same goes for connectivity. Out of the 5,400 connectivity issues that our system detected, we were able to solve about 5,100 issues. So it dramatically reduced the involvement needed by our IT teams and our NOC as well in trying to diagnose and troubleshoot some of these issues. What it did was it gave us a massive increase in throughput gains, as well as a much better performance on a client-by-client basis. And we'll look at that in the next slide. Let's go to the next slide, which is more about what kinds of performance are we seeing on a day-to-day basis. So if you remember, we solved, our AI system detected about 500 issues, and 378 were corrected, 131 corrected. But more importantly, we saw all of those issues during the week. So February 27th over here, I believe, is a Monday, and then through the week. And this is great for our IT guys because they can really focus on things that they need to versus pick up the phone and respond to the same issues from different types of devices. Okay. If you had to quantify the gains, we look at it from a average percentage gain. There's a average gain by user that we see on a day-to-day basis as the week progresses. But the max gain at any time, and this could be any time during the day, off-peak or peak, we start to see an increase. In this case, we saw about 23 dBs per AI action, which is great because every time our AI solves an issue, we see an increase in performance. And we're trying to make this even more predictable on a week-by-week basis. So one thing we need to do better is figure out a way to kind of benchmark the data from one week to the next and start to see patterns on a daily basis, which would be great because then we know when to expect the types of issues that we normally see. But in this case, we saw about a 23%, 23 dB gain in AI for AI action. On a connectivity basis, out of the 5,400 detected, 5,100 were corrected. We try to classify those by the types of issues. 802.1x made up a chunk of those issues, followed by some other issues that we're still trying to classify as, whether they're authentication issues that originate from the client or whether they were network-related issues. And then IP issues are those related to DHCP and timeouts. The net out of this is that we got a productivity gain of at least about 18 hours with machines solving for these issues. This is awesome because this is basically 3 days worth of productivity that our IT team gained by not having to deal with these kinds of issues themselves. We'll show you really quickly some of the views that we see on an access point and device basis. For example, in the access points, our AI can show us how to find glitches in the Wi-Fi system and take the guesswork out of the troubleshooting process. A lot of the times that we find ourselves looking at the wrong access points or the wrong devices, we really don't know how to stack rank the issues. Our system attempts to report on the detected, correctable, and uncorrectable issues. We can help to drill down by AP location and the radio, and then you can see a summary to find systemic AP issues. Because there are APUs that are causing systemic issues, you want to be able to isolate them and find out if this is a one-off issue or if it's a system-level issue. And the same goes for devices as well. We can fulfill performance and connectivity issues by device as well. So you can see that in the next view here. Okay. So this is what we see at this point. Our AI points our NOC to the APs with systemic issues, so the NOC can take well-informed actions when necessary. For example, over here, what we see is a large number of detected issues and corrected issues, which is awesome, but it also shows us a few uncorrectable issues. Now, to us, less than 5% of uncorrectable issues implies there's no systemic issues, so no action really needed on IT. Whereas over here, out of about 100 plus issues, close to 100 were resolved, but a large chunk of issues continue to be unresolved or uncorrectable. So this is a warning sign, and we would like our IT to be notified that there are some access points out there that could have systemic issues, and it might be time for them to look in and take a deep dive. But it clearly eliminates any need for IT to look in the wrong areas and spend a lot of time troubleshooting and identifying issues. We'll show you really quickly some of the views that we see on an access point and device basis. For example, in the access points, our AI can show us how to find glitches in the Wi-Fi system and take the guesswork out of the troubleshooting process. A lot of the times that we find ourselves looking at the wrong access points or the wrong devices, we really don't know how to stack rank the issues. Our system attempts to report on the detected, correctable, and uncorrectable issues. We can help to drill down by AP location and the radio, and then you can see a summary to find systemic AP issues. Because there are APUs that are causing systemic issues, you want to be able to isolate them and find out if this is a one-off issue or if it's a system-level issue. And the same goes for devices as well. We can fulfill performance and connectivity issues by device as well. So you can see that in the next view here. Okay. So this is what we see at this point. Our AI points our NOC to the APs with systemic issues, so the NOC can take well-informed actions when necessary. For example, over here, what we see is a large number of detected issues and corrected issues, which is awesome, but it also shows us a few uncorrectable issues. Now, to us, less than 5% of uncorrectable issues implies there's no systemic issues, so no action really needed on IT. Whereas over here, out of about 100 plus issues, close to 100 were resolved, but a large chunk of issues continue to be unresolved or uncorrectable. So this is a warning sign, and we would like our IT to be notified that there are some access points out there that could have systemic issues, and it might be time for them to look in and take a deep dive. But it clearly eliminates any need for IT to look in the wrong areas and spend a lot of time troubleshooting and identifying issues. This is a bird's eye view for the NOC. At any given time, our NOC can view a comprehensive summary of the issues and then take appropriate action. So this is a view that our NOC sees. It's not necessarily a view that the IT team needs to see. It's just way too much detail for a very little return in time. But we can provide the summary digest of all the issues, where they occurred, what was done to resolve them, and so on. Our NOC gets this bird's eye view at any time to be able to take that action. Finally, and in closing, proactive AI aims to change the game for Wi-Fi network operations. So what this means is you as IT now have a wingman, and think of the AI system as your wingman as you scale the number of users and devices that you need to support. Preemptively respond to issues before they're escalated. Clearly identify issues that show systemic issues and take action. There's no tweaking of RF knobs needed, no more rebooting APs, no more on-site firmware updates if you're still doing those. And then avoid backdoor control measures, because users expect to be able to access any type of device anywhere, anytime. So throttling bandwidth or blocking users without a clear understanding of what's causing the performance degradation could actually result in some user dissatisfaction. What this means for end users is that they receive excellent coverage and faster download speeds everywhere. We see that in our office here in Octave, and we never really have to worry about download speeds as a barrier to doing any kind of application or launching any applications. Confidently switch to wireless LAN as a primary mode of internet access, as we have here at Octave, and then rave about the cool workplace experience, because there's something that a lot of employees want to have is the ability to talk about the Wi-Fi network and the fact that they can launch any applications and never have to worry about opening cases or tickets with IT. I think this system will aim to help them accomplish that. Okay. So with that, let's move to some Q&A. I know we're a little bit over the time here, but hopefully you got a lot of value out of the discussion and the presentation. So Emily, do you want to pull up the Q&A?
Absolutely. Let's see. Our first question is from Tony. He would like to know, what is the cost for this?
The cost for the system. So that's great. We have a pricing schedule that is a subscription pricing model. If you contact us, we'll give you a quote based upon the network that you're supporting, the number of employees that you have. But our goal is to make it as affordable as possible so that you can get in and start experiencing the Wi-Fi experience. So it's a subscription price, and we can provide you a quote based upon the number of devices and employees and square footage.
Great. Jacqueline would like to know, can you tell me how your solution compares against competitors like Meraki, and can you help me understand your competitive advantages?
Awesome. So we think of ourselves as the next wave of cloud Wi-Fi networking. Solutions like Meraki will point you to the statistics. They'll tell you what's happening in the network in passe. What we're doing is actively going there, and our system takes care of all the issues. So while a Meraki system, for example, might show you that you have a number of access points broadcasting certain SSIDs, here is the speed that you're getting by radio, these are the number of clients that you have. It's good information to be able to know what you have, but it's a different experience to know what's getting resolved. And what we do is we actually proactively resolve issues before you notice them. So our differentiation is that we proactively use AI to resolve issues that are mostly unnoticeable and that go under the covers. We prevent escalations from occurring because we can resolve them in real time. We have a 24/7 NOC that's monitoring the network, unlike a Meraki or other competitors. So no wireless LAN troubleshooting is complete without looking at the LAN. So what we're looking at is not just the RF, but also the DNS, the DHCP, if you have a radio server or a AAA server. We're experimenting a lot with our own technology. In terms of the WAN, this is an area I think depends upon the way you've designed the network. So if you're getting backhaul from an ISP, then what we can do is show your ISP, or our system can show your ISP the last mile issues and the performance in the last mile, and hopefully it gives you more leverage in being able to ask for a much better performance tier from your ISP. But we can't solve WAN issues because our technology doesn't yet go there. But we can show you the analytics that you can take back to your ISP that's providing you the WAN.
All right, great. Do I need to train the AI system to recognize my environment at all?
No, the system is designed to be auto-detection and auto-tuning. So what this means is the moment you plug in your access point, once you set up your profile and your user and SSID, which basically takes 3 to 5 minutes, the system is on cruise control. It detects the users and the types of clients that are connected. It It automatically tweaks the performance or the channels if it needs to. It switches channels on the fly. It attempts to eliminate link quality issues and cell size, coordination that you might have to traditionally do with a competitive product. All of that is done automatically. So the auto-tuning is something that our system does on the fly, and then it provides you a report to tell you what was tuned to get what kind of outcome, which is huge because you don't see that kind of an outcome with a traditional vendor. You have to literally go in and tweak the knobs and then take a spectrum analyzer and go out there and try and measure the performance, or ask a user as well, your application is loading faster, are you going to go to download speed, you do some speed tests with some apps. I mean, it's the whole process with a traditional solution is very cumbersome. With our solution, you get a digest of the actions that were taken for tuning, and then it also tells you where the problem occurred and what the symptomatic issue was.
All right, great. Let's see. Do I need to understand the inner workings of the AI system at all?
No, you don't. In fact, this solution is designed to be sort of like an Uber experience. You just set up your users and your access points once, and then they run on their own. It's an on-demand service, so you get access to your system when you need it. You can see all the statistics that we just shared with you. You really don't need to go in there and understand what the AI system does, what kind of rules were developed. I mean, most of the rules we develop are based on workarounds and diagnostic techniques that experts have perfected over the years. So it's not something that is unknown to you, but at the same time, it's a lot of technical detail that you really don't need to worry about.
All right, fantastic. So we are going to cut it off there, but we still do have some questions, so we'll get to those offline. Thank you so much for that presentation. Nilesh, do you have any final words for our audience?
First of all, I want to thank you guys for joining this webinar. It's our third webinar, and we've been very impressed with your feedback and your guidance, so really appreciate that. We'll continue to work on all the feedback you're providing in this seminar. Stay tuned for updates from us by checking out our blog, or if you're signed up to our service, we hope you enjoy it. And please do provide us the feedback because that's what makes the solution even better. We have a website, art2wave.com, that has additional detail, and we'll continue to provide more detail on the use cases as we see it in our own network. So we'll continue to share it offloading our own network. But beyond that, thank you so much for your time,